So, as I said, when A is positive, we're looking at exponential function. So, we have an A is positive, let's go with 5. Okay? And you can use decimals to help you look at it because you're just looking at the pattern and seeing what's going on. But if we have a 5 there, A is positive. Okay? So 0 in for x, 5 times 1, which is 5. Right? If I put a 1 in for x, 5 times 2 to the first, we're going to get 10, which is way up here. Okay? If I go negatives, 5 times 2 to the negative 1, 5 times a half, 5 halves, which is 2.5. So it's going to go this way. Alright? So it's going up to the right of the x-axis. Okay, so it's increasing. If your A value is negative, we're going to look at a pattern where it's negative. So negative 3 times 2 to the x. And we do the same thing, we make an XY table and graph this one when it's a negative. Put 0 in. So you get negative 3 times 1, which is negative 3. The 1 in for x, negative 3 times 2 to the first. So negative 3 times 2, which is negative 6. So negative 1 in for x, negative 3 times 2 to the negative first power, negative 3 halves, which is negative 1.5. Okay. So what is the negative in front of the number 2? When your A is negative, what happens? As a decay, it's below the x-axis. When it is positive, it is above the x-axis. Okay? So the A value is going to tell you whether it's above or below the x-axis. It would be, actually, this wouldn't be a decay necessarily. Okay? What's going to affect the decay is the B value, actually. Okay? So the A value just determines if it's above the x-axis or below the x-axis. We're going to look at growth and decay today instead with the zombie activity. Okay, so your A value actually has to be positive for it to be a growth or decay. All right, and the reason is because all of these values are negatives. Okay, if we were talking about something like bacteria growth, and you have a negative number of bacteria, no, you have to start with something positive. So on a growth and decay model, your growth, actually the first example I have here is a growth because it is increasing. As you go along, think of the x's as time. Okay? As you go along on time, it's increasing. So this would be a growth model. If you had a decay, it's still going to be positive values. It's still going to be above the x-axis. Okay? But it's going to going like this. It's going to be decreasing over time. And everything's getting smaller and smaller. So this would be a decay. Alright? Now I know you guys are still working on your graphs. Probably some of you might be done. We will grade those tomorrow. So if you know you're going to go tomorrow and you are finished, you can hand those in before you leave today. Okay? Or you can do now if you want. If you're not quite finished, that's fine. You can keep them in there. You're going to be here tomorrow, and we'll break those tomorrow. Okay? So, everybody get their journal then? When it's above the x-axis, if it's positive, below, if it's negative. Okay? Like I said, we're going to look at exponential growth. Okay? In this activity with zombies. Alright? Go ahead and put these down. Why don't we just hand in your journals today and we won't have one tomorrow? Because there's so many of you going to be gone. Okay? So your drafting assignment, you can hand that in if you are finished. You're going to be gone. Journals, yeah, I'll take everybody's journals, and we're not going to have another journal tomorrow. I'll put those in 3 weeks. Please make sure you're making one. Okay, on your activity here, we're going to talk about it. You are going to work with somebody on it once we get started, but I'm going to get everybody kind of going on it first. Okay? Of course, zombies are fictional, so you know that they're not real. Okay? I guess they could be, hypothetically be real, eventually, sometime. You never know, I guess. Okay? But on here, you start with a certain number of zombies, and then each zombie is going to affect a certain number of people each day. Okay? Now, once they have infected, I guess, someone, and they turn into a zombie, then that original zombie is still, every day, is going to infect more and more. Okay? So it's not like, oh, they infected 2 people or whatever, then they go. No, they're going to continue to do that. Okay? So it is going to grow. So on here it says on June 30th, 2035, a sleeper cell of zombies executed an evil plan 10 years in the making. Their objective, to turn the entire human race into evil zombies. Each zombie can turn 2 humans per day, but they are not sure how long it will take them to completely turn every human on the planet. Okay, so we're going to complete the table below to show the first 10 days of the attack. The original sleeper cell only had 5 members, but keep in mind that newly turned zombies also have the power and the will to turn other humans. Okay? So I am going to kind of get you started on here. Now, when you're doing this, on the back page, number 4, has equations there for you to choose from that would represent the situation. Okay? This is an exponential growth model. Okay? Because they're going to grow exponentially, and you'll see that when you do the table. So out of the equations you have to choose from, keep in mind what an exponential function looks like. Okay? What makes it an exponential function? So some of those choices there are exponential functions, some of them are linear, some of them are cubic. Okay, looks like. So when you're looking at those, coming up with an equation, just keep in mind that you need an exponential equation. Okay? So you can eliminate some of those already without even looking at the numbers. Alright? So I'm going to get you started on the table. And I'm going to let you work with somebody. Now on here, because it is an exponential growth, and then later they talk about an antidote for zombies to cure them. So this would be reversing that. So if they're growing exponentially, and then somebody finds a cure, and then it starts decreasing their population, that would turn it into an exponential decay. So you start with the population, and then it's going to break it down. So really this activity covers both of these. Okay? And when you do that, on the decay one, they don't give you choices for your equation. They do want you to write one. Okay? And your B value is what is going to affect which one that is. Okay? So that's something I want you to think about while you're doing the began to work on that. So, on day 0, how many zombies were there? 5 zombies, okay? So, each one of those turns how many humans per day? We read that in the top paragraph. 2, okay? So, we have 5 zombies. I could number 1, 2, 3, 4, 5, but we have 5 zombies, okay? At day 1, this zombie is going to affect 2. This one will have 2. This one, every one of them is going to affect 2 humans and make them zombies, okay? So on here, it says number of zombies turned each day. Really, it's how many turned plus what were there already. So what they mean by turned in this activity is how many zombies are there, okay? How many zombies there are altogether. So, how many did they create after the first day? 10, okay? They created 10, and how many were there to begin with? 5. So after day 1, how many zombies are there total? 15. So on your table for day 1, number of zombies should be 15. Okay, so now we have 15 zombies. Those 15 are going to turn 2 each. Okay, so this just doesn't keep building. You have 15 of them now. Okay, if each one turns 2 humans into zombies, how many did they actually turn? 30. Okay, they turned 30 into zombies. And there was 15 to begin with, so now how many zombies do we have? 45. So day 2 is 45. Does everybody understand that pattern that we're going to go through? Very good? Okay, so you can get with a partner. You can work on that. On number 2, it does say sketch the graph. You might use another piece of paper to sketch the graph, because some of these are going to be pretty good numbers. Just sketch it on there. It doesn't have to be real precise, but I do want to see a graph drawn. Okay, for some kind for number 2. But go ahead and get with a partner. You can move the desk if you need to. But I do want you to work together on it. Some of the questions later on, it would be helpful to have somebody to talk it over with. So, okay. So go ahead and move if you need to. Get with a partner. If there needs to be a group of 3, there may be a group of 3, or a couple groups of 3. That's fine. Okay.
20.
what? Sorry.
Well, it's more like day 20. At day 20, you hit 5 billion.
Okay, so 3 would be what?
We did ours. We got it on our 18th.
So this is like an X, Y table. So your X's are
I took day 10.
but your Y's are linearly
I just kept tripling it.
exponentially multiply by the same factor.
We did.
So when you multiply by each time, multiply by 3, so that's the common factor. It's triple, it's multiplied by 3 each time. Okay? Okay, guys, keep working on this. Stay focused on what you're doing, get your questions answered. Yeah, you're gonna have a paper, and this is basically your XY table. Of course, some of those are rather big, so you can just grab with it. That's really what I'm looking for. That just means the general equation. A very large slope. Now on your graph, you guys, what I'm looking for is really the shape of it. Yes, I want you to label some things. So our X's, this table you fill down is like an XY table. So your number of day, that would be your X's. Your Y's would be the zombie population. Okay? Now, yes, some of those are really, really big numbers, and I do not expect you to label from 1 to 200 and something thousand, okay? But I want you to graph enough points that you can graph the general shape of your graph and look at the pattern of this following, okay? So the graph isn't going to be real precise. What the data looks like.
So you have the 2.5 minus.
They have the ability to run so they can fit 6 people per day. Oh my god, that would be like 2 days.
So you got to do that minus, no, because that's what the actual line is, so the.
So you take that, so are you gonna just minus 98 minus 6? Minus 98 on 415.
If you're doing the
Okay, no, no, so
So, want to know how many are there on the exam, or how many are? Yes, how many that are. Oh, but they need by turn, it's not like bonus. Okay. Just how many are actually, so it's on the table, so it's the numbers on the table.
Hey, you don't have to press the 3 from 4.
Are you looking at the one where they talked about how many are
She said
turned?
those are turned.
Turned, that means how many total. Calculation.